So I'm going to talk about crowds, and first I want to thank Side Effects for having me here. And I'm going to start a little bit about me. I'm a lead crowd technical director at MPC, and I used to be a generalist in commercials for many years, but then I decided to switch to film, and it was just a coincidence that I happened to be in crowds, and I didn't even know that you could be a crowd artist, but then I really liked it, so I stayed. And then I'm just going to talk just about MPC. So MPC, we're pretty big, we're 3,000 people, and we are in London, Vancouver, Montreal, Los Angeles, and Bangalore. And they also have MPC advertising, and they have some boutiques in Shanghai and Amsterdam and New York, and probably a few more places I don't remember right now. And just, if you never heard about us, I'm just going to show you a little reel, what we're doing. So here are some of our current movies, and there are actually many more than this, but I just picked some at random. So we do, small indie movies. So Houdini crowds at MPC. Houdini is actually kind of a new thing at MPC. When I started, not even FX was using Houdini that much. But then now we're using it more and more. So the first thing I'm going to talk about is why we switched to Houdini in crowd, because we actually had a really good proprietary system in crowd. So I'm going to talk about that. And then I'm going to talk about our core crowd toolset that we developed. And then I'm also going to show a case study of the film that drove the whole process. And I'm also going to give some credit. When I started with this project, they actually had done one Houdini movie before, and that was Alien Covenant. So they created some Houdini tools for that one. And they also created some Houdini tools for the pitch for Nutcracker, which is a case study I'm going to talk about. But when I started, we decided to scrap most of those tools that were developed for that because they didn't really work how we wanted them to. But I still need to give some pioneer credits to Adam Davis and Phil Roos that were creating the first tools there. And then also Chris Spending was helping with that. And he's the reason why I'm here in the first place. And he's head of the department of crowd. I remember him, he called me up. I was working at ILM at the time, at Ready Player One. And he called me up and said, oh, I have this crazy show and it's going to be this massive creature. It's going to be built out of mice. We're going to have a big battle. And I just want to do it in Houdini. And I want you to come over and you should be the lead. And I want you to help me to develop this framework. And obviously I was there immediately because that was super cool, I thought. So in the beginning, it was just me and Chris that was doing all the core tools. Then obviously we had like a lot of Houdini TDs, so they did other tools. But for the core things, it was us two. And then later, Sam came in and is our department software guy. And he's been really helpful with pipeline stuff and stuff like that. And then I want to give a special thanks to Felix and John. Not only did they do a lot of cool stuff themselves and cool tools, but they're also very good with feedback. So thanks to them, everything looks like they do today. And then I'm going to give an additional thanks to the whole Nutcracker team because they were really patient with me. I completely broke their scene so many times when I was updating the tools. And some of them also did really cool tools themselves. Right. And so before Houdini, we had our own crowd proprietary system called Alice. And it was actually pretty good. So here are some of the shows that we did in Alice. To start with Troy. And I remember World War Z was before my time, but I remember when I saw the trailer for World War Z, I was completely blown away by the crowd there. So yeah, it was quite capable actually. So why switching from Alice then in the first place? So the first thing, it couldn't handle flying agents that well. So a matter of fact, when I came into MPC at the beginning, it was just because they built this soft marsh system for flying agents. And then I was a soft marsh guy, so I came in because of that. And ironically enough, that was also around that time that Autodesk canceled soft marsh. So we were in this room with disgruntled soft marsh people, which was intense. And then another thing, it's not very user-friendly. It was very generic errors. It broke really easily. And I remember just getting through the training in the beginning was kind of a pain. And then obviously it was a small pool of artists. Not that many people knew Alice. And it was also hard to keep people because should they invest all that time in this software that was only used at MPC? And then it was simulation only, which sucks. And then it had an old architecture. So it was like part of it was based on Mel. It had some C++ core and there was all these layers around it. But the next question, okay, so we are changing software, but why Houdini? And we had a couple of reasons. The first one was it had an excellent crowd system out of the box since 15.5. So side effects added a lot of features that we really wanted. So one of them was, for example, locomotion. If you don't know what locomotion is, that is when you take an agent clip, strip out the motion of the agent, put that in a separate channel, and then you drive the agent with that. And I have this little video to show what that means. So they are both playing the same clip, but one of them just have a constant speed, and the other one is using the locomotion channel. And obviously, when you have variable speed, that is the way to go. And then also we have a nice way of cutting up clips. So here we have just one clip. I'm just doing all this like sub clips from it. So I have an idle to walk and I have an idle. And everything comes from the same clip. And the good thing I'm doing a thing like this is that it's going to merge and blend very well together. And you can do that with a transition graph, which was also another big point in Houdini. It's really nice how it's handled the transitions. So here you can see this little chart shows I have transition between the different things here. So I have an idle to walk, and then a walk, and then a walk to idle, and then back to an idle. And the cool thing with the transition system in Houdini is that I don't have to first trigger the idle to walk and then a walk. I can actually just go and say, I just want to go to a walk. And you can see that here in the simulation. I'm just doing an idle to walk, and then a walk to idle. And then Houdini is clever enough. So it looks, is there a straight path? And if it's not a straight path, then it's just going to find a path to that. state. So here it's going to go through that idle to walk state. So that was really good. And then you can easily do a thing like this. So this is just like a 5-minute setup using one clip. They get triggered by the box, and then this grid makes them stop. And obviously, if you would do it for a show, you would tweak it more and have more clips. But I still think just for using automatic transitions, as I'm using here, it still holds up pretty well close to the camera. And then, of course, side effect listen to its users, and everyone knows that. It's weird that you can give them a feature request, and then immediately in the build the day after it's there. And I don't know how that's possible. And then one thing I think a lot of people misses when it comes to when you're comparing different crowd systems is that you actually want to see on the agent definition, and it's really good in Houdini. So you can take almost anything, can be a crowd agent, and then you can go in and read anything from that crowd agent and change it. So I've done this little example here, and it's a really lame example. It's just because I can't show like our actual code for our actual tools. But so here, for example, first, I just want to add some offsets. It's just playing this clip. And I have a wrangle, and I just want to add an offset to it. So I just take the clip time, add an offset, and then I drive that from the control over here. So then I have an offset there. And this, of course, is like a really simple thing. But then I can do more. So I can go to this, I've set up this transformation group. So I want to blend something with that group there on the left arm. And I set up this pose here I want to blend from. So I just did an agent edit and post him in like a weird way. And I want to just have the left arm from that. And that is really easy to set up in Vex. So then first I just take the left branch and the right branch. I read the transforms, put them into 2 arrays. I also take all the waste and put them into an array. And then when I've done that, I can just go to the next node. I could have it in the same node, but just for make it clear. I just loop through the arrays, and then I do a blend based on the transform weights. And I also multiply that blend with another blend I have on the controller. So here I have this blend over here. And then you can just blend the animation in here. And obviously this is like a super simple example, but it just to show that it's quite easy to build tools from the crowd system. So here I'm going to show you, so this is like a real example, a node I did for procedural bending. So we have these mice, and I wanted them just the tail to bend, and I also wanted the body to bend. And then quite easily, I could just build a tool for that, which is cool. And then I don't know, I did flying mice, but yeah, there they are. And then here's another example I did. We had a problem because we had a lot of mice, they were running, and and the tails either got really straight or got animation clips, and you saw the duplication. So I just added this system to add a procedural motion on top of the animation. So first I had just like an animated noise, but you also had this position-based noise I'm showing here. So now it's based on the position, and it worked really well when it was running fast. And then the third thing that was a bit tricky with this whole thing was that the tails tend to go through the environment because, and so then I wanted to have like a solution for that. So then I just made this very simple terrain project. And things like this is quite easy. If you just know a little bit of vector math, you can do things very easily in Houdini. So that was a strong point, obviously. And then another thing, the fourth thing that a lot of people don't know, you may know it, but it's that a crowd is always live. So even if you cache something, you can keep working on it. So this is from a masterclass I did a few weeks ago. So I have this cached simulation here, and then I want to add ragdolls to that. But instead of redoing that simulation, I just add another simulation on top of it. So here I'm adding that second simulation, and now I have these guys falling over. And it doesn't even end there. I can add post tweaks, and this is something we do a lot at MPC. So we use agent edits, and then we just add we keyframe things on top of the crowd. So it used to be that we had to promote everything to animation, and what that means is that you take your crowd agent, and then you promote it or convert it to a rig that animation can use, and then they animate on top of it. But now, just because we can do it this way, a lot of time we don't have to promote it and let animation have a go at it. We can just keyframe it in crowd, which is super powerful. So yeah, so I'm keyframing his head turn there. And then obviously it's great for simulations. So we can combine different solvers. It's really fast as well. Like a thing like this, you can just do on your laptop. and is stable as well. A lot of systems have problems because they're building up power and explodes, but not in Houdini. And then, of course, we got a large pool of artists that we could recruit from. So now we have all FX TDs as well, and that's been really good for us. We have a lot of people and get knowledge into the department. And then one of my favorite things is it's so easy to debug, because it used to be, I found with other software, if I get an artist and it's broke for some reason, they always have to tell me a story because it's not that obvious, like what has broken. So then they have to say like, oh, I rotated the camera, I pushed this button, and then something happened. And then I'm like, oh, from my experience, I know it probably this thing happened. But in Houdini, I can just look at the spreadsheet and then just go through it. So they don't have to tell me anything. And that is very nice. Yeah, so here's the summary of all that. So then we had some goals when we wanted to do this. So the first goal was we wanted to be easy to use, even for non-Houdini users. But at the same time, we wanted to be flexible enough for senior artists, because it's nothing worse than a black box, and they are like, they have to use the same workflow that they are not used to. So you can override any part. Also, as little simulation as possible. Simulation is always nice, but for crowds, a lot of times you just want to tweak a little thing, and a lot of crowd, you don't need simulation. So we want to have that approach to it. And also, we want it to be integrated with the pipeline. It should be really easy to get assets and also release it to the pipeline. And last of all, we want it to be modular and easy to expand. So first thing I'm going to show here is how it's connected to pipeline. And this was Chris Baby. He did all the user interface. So here you can see, if you're going to gather an asset, you just go to this agent gather, and then you gather, and then you choose whatever agent you want to gather. And then you go to the clip browser. It's connected to our mockup library. And all these things, by the way, they just add the regular side effects nodes. But yeah, it's just packages in this way, so it should be easy to get started. So now I'm gathering those clips here. And then I need to assign them to an agent. So take that one, assign those. And I can assign multiple clips at once. And this will obviously create an agent clip node, if you've done any crowds before. So then we have them. And then to create a crowd, you create an agent. That is our name for our crowds. And then you have like our specific frameworks. But now I'm just creating a DOP framework. And this is just a standard Houdini crowd. So you will see when I turn those off and go into this one. Right, you can see it's just a standard crowd setup within Houdini. And then when you're done with your crowd, you can always, then we have this release thing. So you create a crowd package, and that is the thing we release to our pipeline, so other departments can pick it up. And it also takes care of naming, because we have a certain way we name different variations. So this takes care of all of that. And then it's just, and then you can just release it with this big release button down there. And here's another example. I have this kid here, and I want to use the same clips that I used for the adult. And then I assign it, and I create a crowd. And obviously, his proportions are not the same as the adult. So if I create a crowd here, another DOP network, you can see now his proportions are not really right. So then we have another thing we can do here in clip properties. So clip properties is, by the way, another way it's actually connected to a lot of different nodes. But then we just have it in like the same place. It's connected to agent preps, to the agent nodes, to clip properties and stuff like that. But then you can also right click and you have all these operations. You can do mirroring, you can do retargeting, and you can do foot down. So in this case, I'm just gonna choose retarget. And just by doing that, so now it's retargeted. And this is actually just creating an OTL node with a chop network in. So, and it's really cool that we just can use chops. Chops is super useful. We use it to many things. So it's not only retargeting, we use it for mirroring as well. And then another thing that Sam did, he made it possible so you can go and pick up the textures from the pipeline, and then it will automatically create material style sheets for them. So here you can see, you just click this visualize button, And then now suddenly you have the textures from the pipeline. And then if you take out the tools we created. So the first thing I created when I got there was a clip player. And most big companies have a clip player. And an agent edit is kind of like a simple clip player. But then, so it basically just means that you can play a clip and place it around, and it will be procedural. But we have like a different flavor to ours, of course. So here I'm just going to show you the workflow. So you add some clips here. So now it's just playing one clip. It's just playing it with no modifications. But then you can select to loop this guy. So I can set a loop range. And this is driven by locomotion, by the way. So I set a loop range. And now I have just a loop clip here. And I can do a blend. This can also be connected to clip properties. So now I have this guy running there. And then I also thought it would be cool if you could do blend between two loops within the same clips. So you can also make a start loop and tell it to loop another thing a certain amount of time, and then just blend over to the other loop. So now he's starting an idle, and then he goes over to that run loop later. And then, of course, this is not much of a crowd, so you can connect like a point layout. And now you have all these agents here. And then you can do all kinds of, like the normal things. You can do a random frame offset. You can do random speeds, random size, all that. You can see it's still procedural. It's really quick. And because it's using locomotion, you won't have any foot sliding. You can also go into individual agents and select them. And then just offset the frame. So here I offsetted that 50 frames. It's really useful if you have two agents that have the same pose and you get a note on that. You can just select that agent and then offset that frame. And then this is cool. Oh yeah, we have another thing here. We have mirroring. So you can do mirroring to get some variation. And that is, like I said before, that is connected to this chop that do the mirroring for you. And then you can, of course, add all these kind of clips in here. So now I'm adding a few clips here, like a few walks. And then it randomly assigns them. And you can see one of the clips, if you take the guy at the back, is falling down and kind of obvious. And then, of course, you can use clip weighting, so you have less of that guy, like so. And all that is cool, and you can, of course, change the orientation, stuff like that. But I also felt you had to have a way to control it. Even if you want the clip to drive it, you would be able to like bend it a little bit. So then I added this way of deforming locomotion with curves. So I have this, by default, it's just randomly picks a curve and starts following that curve, which is a bit confusing because it's just like this mess of guy running everywhere. But then a better option is just to pick the closest curve, and then you can see that they are following each other. And then the next thing is that you can just do one agent per curve. And then the thing we had in Alice that a lot of people used, it was they have this multiple curve setup that created a vector field. So I thought I need to have a similar thing in here. So then I created this way of creating vector fields. So here, if I visualize that, so it's same curves, but if I visualize that, you see all the arrows here, and then you see this like the flow field. And so then they started following that instead. But it's still procedural, so it's still no simulation. And also you have, I should have zoomed in here so you could see their feet, but they are not sliding because they are using the locomotion. And this was like one approach. So this first approach, oh wait, I'm going to show you this as well. So another thing we call it vignettes when we mocap things with 2 or more people. And then so we have support for that. So this is actually mocap like pairs. So then you can just use this children thing. And this works with horse and riders and stuff like that as well. So that was like one approach, and that is that you're using the clip to drive the motion. But then sometimes you won't have complete control. So you just want to place the position points exactly where you want them, and then the clip playing should try to adapt to whatever you do with the points and with your agents. So then we did this other way of doing it, and it was this motion path framework. So and you can override any part of this, but if you use like every node here, you start by like just drawing a guide curve, And then you drop down motion path node, which I do there. And by default, it's kind of boring. It's just have like a lot of similar curves, like following the guide curves. But here you can, of course, you can sculpt it in different ways. So you can have these random overlaps. You can add some noise to it. And you can also have these different ramps that drives different things. So here it's driving the rotation. What I'm not showing here, you can also have, can terrain project part of it, and then have a ramp that blends what part is terrain projected. And then a thing I had to do, which you understand in the case study, is I also needed to have it be able to deform to animation. So here I just have this animated grid. I have an animated bend on this grid, and then you can just have it deformed by that. So you have your motion paths, and so then the next step is that you need to have some movement on those paths. So then you add this other thing I call move along path. And with the move along path, I'm just showing some basic things here. You can actually do quite a lot with it. But by default, you just do this stream of agents. So you can just see it's like continuous looping. And the reason why this is working when you're rendering it, because I have set this attribute, so I hide the agents in the beginning and at the end in Katana, so then you don't get motion blur streaks. But you can do all kinds of things in here. You can turn off the looping, you can have them going in 2 directions, you can have them have formations, you can have them in they can go to a certain frame and form a pattern on that frame. They can they're also setting size and orientation here, even if you can't see it now. So you can have the size to be based on the speed, and you can have banking and all kinds of stuff. So when you have all that, you just need to copy agents on it. So then I have this node called agent copy. And so this takes all the data that you have set in this move along path. Or if you want to wrangle your points yourself, you just need to make sure that you set those data, and then you can put that into the create agent copy. So here I'm just, you can see I just duplicating some fish on it. So this is not even playing a clip right now, but it takes all the data. So it takes all the size and it takes all the orientation from the move along path. And then you can, of course, add a clip. And by default, it's just playing a clip. So it's not really concerned about how fast the agents are moving. So now I just make it move a little bit faster. So now you can see that they are swimming. And in here, you can also make proxies if you have like a really dense crowd. So it's just instances. You can also add other agents. You can have how many clips you want. You can also mix it up with others. Now I have this mice swimming with the fishes. And then I do like different scales and stuff. But sometimes, so this is cool, but sometimes you actually care about how fast I'm moving. So I made this other thing it's also the agent copy, but if they just randomly assign a clip and randomly play it at a certain speed, they just slide and it looks really silly. So then obviously I can't use the locomotion in the same way as I used it in the clip player, but I can like look in it and then say like, oh, it's kind of this speed. So I try to scale the speed based on locomotion. And in this case, it's mocap, so they don't have a constant speed. So you still have a little bit of sliding, which you probably can get away if you add some foot locking to it. But if you have an animation clip that have a constant speed, then obviously it will be spot on. But still, even though you have a problem like the clip selection is still a problem. So you have some of the walking guys, they just walk past the jogging guys. So then I thought, okay, I can do this procedural clip select as well. So you can select clips based on their speed, and then it analyzes whatever clips you have added to the agent, and then it's tried to distribute them based on the speed. So now you can see like all the slower ones have a walking clip, and all the fast one has a jogging clip. And then same thing with ragdolls. We just wanted it to be easy. So this is a little bit like the thing I showed with a ragdolls example before. The crowd is already done here. I just wanted this sphere to trigger the ragdolls. So you add a trigger, and then you add the ragdoll network, and that's that. And you can also connect all the collision geometry in this one, and it's try to break them up and make them bullet friendly. If you have like a concave surfaces, so it's deforming, it have like different things. And then I also added a recovering system. So you have this, you can see these mice here. They're going to recover if you add that on. So now if you play it, you're going to see that they are going to recover when they hit the ground. So a bit slower now. So now they fall down and then they recover and run off. So yeah. Okay. And then the last thing we did, a lot of people always think that you need to do a lot of avoidance in crowd. And sure, sometimes we do avoidance, but a lot of times it's better just to trim out intersections. So we have this procedural tool for that. So what that does is look through the whole frame range and see whoever are intersecting. We have all these filters as well. So you can say just remove intersection within the camera frustum, just remove them on a certain distance. You can also do, if they're behind an occlusion object, don't remove those guys, and so on. And it also tries to be clever, so it loops through all the agents and see how many intersections they do, and then you start removing the guys that have made a loss, like most of intersections. And in that way, it removes less agents. Done.
I think we have time for maybe 1 or 2 questions, if anyone has.
Hello.
Hey.
I want to say to know how do you render the crowd? Is it with Mantra or provide? Or?
You mean as a department?
Yes.
Well, we're quite big. I think we're probably the biggest crowd department. We're like 25 people now. And that's also because we just have one global crowd department. So then we have we do so many shows. So in this, we were like 7 people on this one.
I think his question was the rendering.
Yes,
rendering.
yes.
Oh, wait, sorry. Okay.
How do you export is it a primitive, packet primitive?
Oh, no, because we have our own pipeline. Oh, so we export it as a skeleton cache. And then we have like our proprietary things to skin them, and then they render it in Katana. So, but yeah, I would love to do it.
Thank you.
Yeah.
Hi, Mikael.
Hey.
I'm not very familiar with Agent and Crowd, but I'm a fan of your blog.
Oh, thank you.
And in the beginning of your presentation, you're showing animation in arrays. Yeah. And you're switching from animation, you're blending them. And
little example I did. Yeah.
Yeah, and there is a tutorial on your site, and I was wondering if it was the same thing. You're storing animation in array, and is it some of your own thing, or is it inside the Crowd agent package?
You mean how to read the transforms?
Yeah.
Yeah. Well, it's just because you have all these prim intrinsics. Okay. So you can just read, if you use agent world transforms or agent local transforms, then you get an array from that. Okay. And then you can just use it with set agent word or local transforms.
All right. And I want just one last thing. Yeah. Are you using a lot of old ICE technology? I mean, the States, for example?
Yeah. Well, it's hard to say because now I think I'm using Houdini. Yeah. But obviously because I used a lot of ICE before. So I think I learned math by doing ICE. So I have like a certain way, and probably someone will tell me that that's a really weird way of doing it in Houdini. But so when it comes to math, I do it in the same way as I did in ICE.
Okay. Thank you.
Yeah.
Maybe one more question, if anyone, at the very back.
Hi. Very nice presentation, by the way.
Oh, thank you.
I just want to ask you penetration between the agents when you did all the miles one on each other extra. I don't know, how are you dealing with it?
Yeah, well, it was interesting because when we started, they were from Montreal. They really wanted us to do have like a collision system. So we actually did a rigid body system. But then we just found that when you use a rigid body system, you get a very unnatural, it doesn't look organic. So what we ended up was actually the intersection thing I was showing you. So yeah, we just removed intersections and then we tweaked it a little bit, and then we had certain things to just place them in a convenient place. There was a little bit that I was doing separations and stuff like that, but most of it just removing intersections.
Okay.
Yeah.
Okay. Thank you.
Thanks, Mikael.